Yo, what's going on, guys? Welcome back. Today we are doing episode 9, I believe, of 10 for the Python videos. So basically today we are doing a web scanner. So this is going to scan for vulnerabilities on websites. Let's go ahead and walk through the code. But before we do that, I want you guys to check out the Patreon notes because they are coming along great. You can see here, if you access the Patreon, you get access to all of these cool cheat sheets, different offensive techniques, defensive techniques, walkthroughs, things like that. So it's really coming along. It's really nice. It's really cool. So check that out in the description below. Also check out the Discord below. We've got 1,000 people in there now. We all communicate, do live streams in there and stuff like that. So make sure you guys check that stuff out. Now, let's hop into it. So if you guys aren't following the series, basically what this series is we did 10 weeks of coding and we did 10 weeks of Python coding. And the reason we changed it to Python coding is because we wanted to orient this to hacking, right? So this isn't just going to be regular programs. So you can see here, this program will do web scanners, or is a web scanner, and I'll show you what it does. So let's go ahead and walk through the code, then we'll walk through how it works. So we have import. These are just your libraries that you need to import, right? So you can see we have SSL, certificates, requests, URL library parser, and then sockets, and then the arg parse. So arg parser, if you guys remember, this is what allows us to create the actual help menus on these. It's really nice. It's really handy. I've used it in every script in this series so far. You can see as we walk through it here, we have the arg parser program web scanner. This is a website scanner that uses. So if we run it with tac h for help command, we hit enter, you can see this is what we get. This is a website scanner that uses web requests. Here's how it works. You have to use the target, use the syntax tac t to specify your target. Must be in full format. So it's got to be in the full format. Make sure to check out stuff on YouTube. Now, it's important that we have it in the full format because you'll see what happens. So we go ahead and go down. This arg parse just closes it. This allows us to actually, when we put the tac t and then our website, it allows us to call that later as target.args. So you can see the first one we're doing is web URL scanner. So this is where all of our modules lie. So you'll see that we can add modules or take them out. I'll discuss the SSL one because I might take that one out and change it for something else, maybe like a SQL injection test or something like that. I don't know. So we'll go ahead and look at it. So there's 3 variables that we declare right off the bat: sensitive info, allow redirects, and directory listing. So these are 3 vulnerabilities we're going to look for. So the first one is sensitive info. You can see we're going to look for anything that says password, API key, or email in the source code. So when we actually request something to the website and get it back, it's going to parse through that source code and say, is there a password? And when it's looking for this, it's looking for those words: password, API key, and email. So the reason that's important to understand is because you can actually change this. You can make this say, maybe you don't want email in there because you're getting too many false positives. So you actually do something different, like, I don't know, maybe instead of API key, you do API. Maybe instead of email, you do, I don't know, a specific email if you're looking at website that is a specific target. The other thing to notice here is, see how all of these are in brackets? So you'll see, let's see if we can find more brackets to show you guys, but you can see that they're in brackets. The only one that's not is the sensitive info, but you can change this. The reason for that is because these are lists. They're designed as lists so that you can see when we actually call the arguments down here, it's in brackets. The reason for that is that they're lists. The main reason for that, you can run this scanner against a bunch of websites at once versus just having to have one website and that's it. I will have this available on the GitHub page as well. The link will be in the description, so if you guys want to check it out. So you can see the directory. So now we have the allow redirects. So this is a whitelist. If you guys aren't familiar with whitelists, what it means is if you put a website in this list and the website that you're scanning redirects you to that site, it's going to not tell you. It's going to discard the results. The reason for that is maybe there's expected behavior that you have. So for instance, let's say when you go to this site, it's going to redirect me to Bob's site, right? Like that's the design. It's supposed to do that. Well, if you know that, you're not looking for a redirect that's different than that. So you can put in here Bob's site, right? And then once you put Bob's site, when it redirects, it's not going to pop up and say, oh, there's a vulnerability because you expected that. Then you have directory listing pattern. This is, if you don't know how sites work, some sites will actually list their directories. So they'll have index of, parent directory, directory listing, directory contents, all that stuff. They'll have those sitting there. This will tell you if they list their directories. If they do, you can go to them and you can actually look at all their directories. Why is that important? I don't have to necessarily run a dirbuster, gobuster, or anything like that if they're going to list all their directories for me. So it's a vulnerability. It is an informational vulnerability, but it's still a vulnerability. Now, here is where we get into the meat and potatoes. So for URL and URLs, so we're doing a for loop. So we're running through all of the ones in the list. That's important to know because we're going to do it with one website, but you can do it with a bunch of websites. So here we put headers equals. So this is another variable we're going to declare. This one we're saying our user agent is Mozilla Firefox, Windows. And the reason we're putting all these is because we need the website to believe we're an actual computer. And if you don't do this, some websites will actually give you an error. They won't respond or they won't give you a reply. And it's kind of one of those things, like it may not be very common that you get this error, but it is important that you have user agents. If you've ever looked at Burp Suite or any packet tools, Wireshark, whatever, the user agent is in there. The reason for that is it's telling you who's trying to connect to you, because there's a couple of reasons, but think about it. If you have a site designed for Mozilla Firefox, right, and they connect as Chrome, it may not look proper. So if you connect as Chrome, it may say, here's how it's supposed to look. If you connect as Mozilla, here's how it's supposed to look. So it's formatting helps out a lot. So the header is necessary. So put that in there. You want that header. Now, here is verify SSL parameter for the request. So all this is kind of saying, okay, response equals, so your response, which is what's coming back to you, is your get request. So it's saying get request. Your response is your get request with the URL. Then allow redirects true, headers right there, and then verify the SSL. And we're going to cover the verify SSL because we actually have it set up in here where if it doesn't have SSL, we don't do the SSL check or the cert check. And that makes sense, right? Like you don't want to check a site for SSL if it's HTTP and it doesn't have SSL because it's not going to give you anything. So here's where we start the check for sensitive information. So if we search sensitive info pattern, which is this one right here, response.text. So this is where we're looking at the response of the GET request that we had. And we're going to ignore case. Now, the reason we ignore case is because you don't want to start searching for something and it has to be, for instance, password, and they might have password in there, but it's a capital P, and then you miss it, right? So you want to ignore the case. All right. Sorry, guys. All right. So, and then you can see it's just going to print out potential sensitive information found. So what that means is if it finds one of these, password, API key, or email, or anything you put in there, then it's going to print out potential sensitive information found. Then you can know, okay, let's go back in the URL and check it. And I'll show you guys what that looks like too. Now, check for open redirects. So open redirects, when a website, for instance, facebook.com, if you go to facebook.com on port 80, it's going to redirect you to facebook.com on port 443. The reason for that is because it's insecure, right? A lot of websites redirect you to something, and you're trying to figure out, can I manipulate that? Can I take that redirect and put my site in there when I send a link to somebody? So it looks like it's a legit link, but it redirects to my site. Things like that. So that's called an open redirect. So if a website redirects, you can start looking at open redirect. So first thing I'm going to do is change this to possible open redirect because it may be by design. Okay, meaning it may actually be that way on purpose. It may supposed to be redirecting and it's not insecure, but you want to make sure. So the response.url, so not in allowed redirects. So you can see here's the allowed redirects. This is the whitelist. So if it's not in there, print out possible open redirects found. Now, it's going to say redirect URL. I added this in because I want to see where is it redirecting me, right? And you'll see that anytime it redirects you, it will point this out so you can see where it's actually redirecting you. I recommend you keep this in. It's a little bit causes a little bit more information, but it's one line, and it's hugely beneficial for troubleshooting because if you don't keep in the response or the redirect URL, you have no idea where it's redirecting you to. So you don't know what you're actually looking at, because what will happen is, like I said, let's say I put https www.google and I forget the .com, but it still registers and automatically sends me to .com. Well, that's a redirect. So it will tell me that, and I know that, hey, that site's not giving me an open redirect vulnerability. It's actually just fixing what I did. So now check SSL certs. So this is something that actually happens quite a bit, a very good vulnerability. But basically what this is going to do is it's going to search the SSL certificate and see if it's valid, meaning has it expired? Is it, signed by an actual certificate authority, things like that. And the reason for that is because is it a different cert, for a different, maybe they had an old domain or something like that. The reason for that is because if it is invalid, that means we can actually take advantage of that. So you can see it says if response.url starts with HTTPS. So this is where we're checking. If it starts with HTTPS, meaning it has an SSL cert, this is what we're going to do. Else, we're going to say, then here, you're going to say except, so anything else, SSL certificate for URL is invalid or could not be verified. So basically, we're going to say, okay, if it works, so down here you can see if it has HTTPS, then verify SSL is true. If you remember up here, we have verify SSL. And then if it's false, we're just going to skip that. We're not going to do the verify SSL. We're going to keep that false. So where were we at here? Okay. So if it starts with HTTPS and response.raw connection, cert equals the response raw connection, and then get peer cert. So that's where we imported the certificate. So now if the SSL.match equals host or underscore hostname, cert, blah, 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 hostname, basically if it matches, does the cert match what the hostname says? Again, this is just telling you if it's valid. This is a very quick check. This part caused me a lot of headaches to get built to where it actually worked because of the fact that there's so many sites that have like HTTP, but then it just redirects you to HTTPS and things like that, and that was throwing it off. So there's just all kinds of weird things. So this is a good quick check, but it was finicky. So if you're having trouble with it, I would just comment this out and screw the SSL checks. Because it's not that big of a deal. You can go to a website very fast and see if it's using HTTP or HTTPS. You can also check the cert yourself manually, but keep in mind this is supposed to be for a large number of websites. Check for directory listings. So if response code equals 200 and any pattern in response.txt, so any pattern, here we go. If for any pattern in response.txt for the pattern and directory listing patterns, which is this one. So keep in mind this is a list. We can make this index of parent directory. You can make this a million things if you wanted to. These are just the common ones. It doesn't matter what you do. Then you'll say directory listing enabled for URLs. So what that means is if there's a directory listing, then it will let us know and it will say, hey, there is a directory listing there, so we can go look at it and just get a list of all the directories. I'll just tell you now, big websites usually have kind of taken this out because of the vulnerability. So you may find this on some small websites, but the big ones like Facebook, stuff like that, they're not going to probably have this. They probably won't have a lot of this. The one that will pop on a lot of websites is this email, when it searches for email, because if you ever gone to a login screen, it's going to say, put your email. Every time that email word pops up, that's going to pop up and say there's sensitive information. So that's why I tell you, you may want to take this email out. It's nice because you can know to check for an email in the source code, but it does pop some false positives a lot. So, so now, yeah, this is accept. So if it fails to get anything, it's going to fail to fetch the URL, right? So that makes sense. If there's some reason it can't access it or whatever, it's going to fail to fetch the URL. Now, I will tell you, whenever you use this on HTTP sites, not HTTPS, you're going to always get this failed to fetch URL. That tells you right there that it's, unless you, I mean, you should be, even on a large list, you should only get a handful of these. That tells you right there, if it failed to fetch the URL, it's either not a real website or it is using HTTP. So you can actually just go ahead and check if it's using HTTP, and if it is, that's a vulnerability in itself. So handle SSL, TLS certs verification. Okay, so this is just if the SSL cert is invalid or can't be verified, it's going to print that out for you. And then you can see here, we just specify it. You can see here, invalid URL, please provide a valid URL. That's the reason you kind of got to put that check in, is because if you don't, what'll happen is basically you're looking at putting in a URL that, let's say, is google.com. You risk that it doesn't go to the right site. So instead of just kind of hoping, I force it to put the full link in there. So now that we walk through it, let's go ahead and run it. So first things first, I'm going to run it through the first site, or the only site I'm really going to run it through, and this is because I know what it's going to do, is dictionary.com. So first thing we're going to do is put just dictionary.com, no HTTPS, no nothing, so that you can see. So we put the tag T for target, we hit dictionary.com, and right there you see it says invalid URL, please provide a valid URL. So that's good. That tells us that it's working, it's validating the website, so we need to make sure. So we say HTTPS. Let's do HTTP first, www.dictionary.com. So we didn't do HTTPS, just HTTP. And you can see right here, it says possible. So the first one I want to focus on, I know that says possible sensitive information. So potential sensitive information found. So that tells us right there, there's something in there that matches our email, our URL, or our email API key, or our password. So now, possible open redirect vulnerability found in dictionary. And the reason is, it says, you notice it automatically redirects us to HTTPS www.dictionary.com. So the reason that's really nice to see is because we know that it's automatically redirecting us to HTTPS. So it took our unsecure connection and it redirected us automatically to a secure connection. So now what we can do to validate this is we can take this and we can run it again with the exact website that it told us it redirected us to. And you can see it actually is still redirecting us. So my guess is it's actually probably hitting a web face and redirecting. But you can see that the potential sensitive information is in there. So what should we do? We should go to, let me pull up a web browser and go to dictionary.com. And actually, we'll just do it this way. We'll make it even easier on ourselves, right? We'll go to PowerShell. We'll say dictionary.com. Okay, so here's all the response we got from dictionary.com. So now let's find. So first one we're going to look for is password. Okay, there's no password in there, so it's not password. API key. There's no API key. Email. Oh, look at that. Right there it says enter your email address. Enter your email address. Email address. Email address. So it's working. It's scanning, and it got all these emails. Now, this is obviously, enter your email address is not a danger. It's just asking us to enter our email address. So that's why I say you can take out the email and substitute for something. But it would be dangerous if it said email and then there was an email attached to it, meaning, let's say you go to like a contact page of a website, right? There's going to be emails listed, right? This would tell me that those emails exist in there, and I would go through and I would get those emails, and now I have targets. So that's one of the reasons why I keep the email in there, because yes, it's a pain in the butt, but it does allow me to actually go ahead and find emails. So that's why I like about it, because I could take a large amount of websites, throw it in here, and quickly I'll know which ones might have some emails in. So hopefully you guys like this. Hopefully you guys have some ideas, because in the Discord, in the YouTube comments. I want to see the best ideas I can for Python number 10, because that's the last one of the Python challenge. And I want to come up with something cool. I want to create something cool. And I'd like to see what you guys think and what you guys think we should do, so that, because the 10th project should be big, and it should also be something that everybody can use and have fun with. So hopefully you guys like it. Hopefully you guys enjoy it. Thanks, guys. Have a good one.